Let's look at another way that we can differentiate a function. Obviously we've just had a look at what we call first principles, but we saw that it can take quite a while to do the calculation. So there is actually a much quicker way to do differentiation. So let's have a look at that now. So if I were to write this function out here, y is equal to ax to the n, and a bit of notation, a and n are both constants or numbers, and x here is our variable, or y and x are both variables. Then if I wanted to work out dy dx, it's simply going to be n ax to the n minus 1. Now all this notation is really saying is that first I'm going to take the power and I bring it down the front. So that's where this comes from. This is really the first step for the derivative. Take whatever the power is, bring it down the front. That's why we have an n here. And the second step is to take 1 away from the power. So for example, if we had the equation y is equal to 3x squared, and we want to get dy dx, the first step is to bring the power down the front, so that'll be 2 times the 3, and then you take 1 away from the power, so 2 minus 1, and then if you neaten that up, that will be 6x. Let's look at another question. So here's our function y equals 4x cubed plus 5x to the 4. Again, we're going to do dy dx, and the important thing to highlight here is you can actually differentiate each one of the functions and then add the answers together. So that's true when there's a plus or a minus here. So here then it's just going to be taking 3 down with the 4, so 3 times 4 x to the power of 2 plus 4 times 5 x to the power of 3, and then we can neaten that up, so that will be 12x squared plus 20x cubed. So what I want to highlight here is if you've got 2 or more functions that you're adding together and you want to take the derivative, just differentiate each term in turn and then bring the answers together at the end. Let's have a look at a few special cases. So imagine we wanted to differentiate y equals 2x. I'm just going to write the answer quickly here. The answer is just 2. But how can we prove that using the rule we were just doing in terms of bringing the power down and taking 1 away from the power? Well, remember 2x is actually 2x to the 1. So if you bring the 1 down with the 2, and then you take 1 away from the power, that's really 1 minus 1. So that will be 2x to the 0, and obviously anything to the power of 0 is 1, and so the answer is just 2. But I wouldn't recommend doing this process here every time you're differentiating like 2x or 3x. I would just really learn this principle that if you want to differentiate ax, where a is a constant, then the derivative is always just going to be a. Okay, and what about another special case? Let's say you wanted to differentiate 5. Okay, well the answer to that, the derivative of that, is simply going to be 0. So again, we can kind of prove it from first principles here, but I would just learn this process that the derivative of any constant is 0. So if you had y is equal to a, where a is any constant, the derivative of that is always 0, so remember that. Let's look at another example. So y is equal to 5 over x squared, and we want to differentiate this. Now, if we go back to that form y is equal to ax to the n, we notice that to be able to differentiate this kind of thing, we really need part of the question to contain x to the power of something. But if we look over here, we don't have that at the moment. We don't have x to the power of something. We have 5 divided by x to the power of something. And so we need to rewrite 5 over x squared in what we call index form. And this is probably half the battle with a lot of differentiation. It's being familiar with all the different rules of indices. So I would recommend going back and looking at the videos on that. But what we're going to do then is rewrite this as 5 times 1 over x squared. You can pull it apart in that way. And then that is going to be the same as 5x to the minus 2. And now this is really in that form ax to the n. This is what we want, and then we can differentiate it from there in the normal way. So bring the power down with the 5, so that would be minus 2 times 5. And then x to the minus 2 minus 1. Just be careful here with these minuses. See a lot of students going wrong here. So that's actually minus 10x to the minus 3. Okay, let's look at this question. A little bit more challenging, obviously. So we have to manipulate this equation into a manageable form. The first thing I'm going to do here is to split this large fraction into multiple fractions. So we're going to do it like this: 2x cubed over 2 root x plus 18x7 over 2 root x. So if you have that, certainly in first year differentiation, if you have a large fraction like this, the only way that you can really deal with it in terms of differentiating it is to split it and then differentiate each term individually. In year 2 you will be learning other techniques, but at the moment this is all we can do at this point. Okay, so the next thing we're going to do is cancel it down. So let's have a look at how we can do this. So we can divide the 12 by 2, which is 6, and then it will be, let's write it as x cubed, and I'm going to write over, instead of root x, it's going to be x to the half. So that's something important to remember, that root x in terms of what we call index form is x to the power of a half. And then we do the same with the 18 over 2, so that's going to be 9, and then x7 over, again, x to the half. Now what can we do here? Well, remember, we should always be having in the back of our head that whenever we're trying to differentiate, we really want essentially some kind of x to the power of n type term, and then we can differentiate it. Now the problem looking at this here is we've got an x cubed and x to the half. They're two different x terms, so we would like a rule that combines these two x terms as one, and we do have that rule. It's going to be x to the a over x to the b is equal to x to the a minus b. So we can apply that rule here. So it's going to be 6x 3 minus a half, which is 2.5, which is 5 over 2. And I would suggest that you always write these kind of differentiation questions in fraction form, not decimal form. It's much harder to deal with in decimal form. Okay, and then the next term plus 9, and then same idea, x to the 7 minus a half, which is 6.5, which is 13 over 2. So here's our function. So we've done quite a bit here. We've gone from this large fraction and we've cancelled it down to this. We've got two terms now, and we can differentiate each one individually. So let's do that. So the derivative then, now in the normal way, is going to be 5 over 2 times 6 x to the 5 over 2 minus 1 plus 13 over 2 times 9 x 13 over 2 minus 1. So let's neaten this up a bit. So 5 over 2 times 6 is going to be 15 x, and then you can change 1 into 2 over 2, or you could use a calculator for this. It's up to you really. So that will be 3 over 2 plus here, this is not really going to be a nice number, that will be 117 over 2 x, and then we can do this process again. 1 is the same as 2 over 2, so that will be 11 over 2. So this is your derivative here. Okay, so let's look at this very important concept of what dy dx actually tells us graphically. So here's the definition. Make sure you learn this. I see a lot of students not be aware of this full definition. So dy dx gives the gradient of the tangent to the curve y equals f of x at the point x. So initially maybe this seems a little bit confusing, this phrase, but let's try and understand it. So here I've drawn a curve, and I'm going to call that curve y equals f of x. And I'm going to draw a tangent. Now what is a tangent? A tangent is simply a straight line that just touches a curve at one point. So here's a tangent here, for example. I could draw a tangent over here. I could draw multiple tangents around this curve. But let's look specifically at this tangent line that I've drawn over here to the left. So if I wanted to work out the gradient of this line, I mean, just by looking at it, it looks maybe 2 or 3 in terms of the gradient. How can we work this out? Because normally when we want to work out the gradient of a straight line, we require 2 points on the line. You know, the gradient is the change in y over change in x. But here, if we draw a line that just touches the curve once, we've only really got 1 point on that line. And so the way you can work out the gradient in this case is to do dy dx. So also we have to take into account that dy dx gives the gradient of the tangent to the curve at the point x. What do we mean by that? Well, what we mean is if we were to draw a line kind of directly down from here to the axis, now this looks about maybe minus 1.7, this is our point x. Okay, so the gradient of this line is different to this gradient here because this x coordinate of the point of intersection is different. And so a lot of the time, because the x coordinate of the gradient is different, the actual gradient itself will be different. So let's look at a specific question to understand this further. So let's say that the equation of this curve that we drew was y is equal to x cubed plus 2x squared plus 2. That's like our f of x. And we want to work out the gradient specifically of this line, of this tangent here. Well, we know that dy dx gives us the gradient of the tangent. So let's work out dy dx. So that's going to be 3x squared plus 4x. You remember that when you differentiate 2, it goes to 0. And you can see that this dy dx has x in it. So really, the gradient is a function of the x coordinate. So as this x coordinate changes as we go around this curve, the actual gradient will be different as well. Now, let's say that this coordinate here is going to be, let's just say it was minus 1.7. Okay, so then how do we work out the gradient of this line? What we do is we sub in x is equal to minus 1.7 into here and here, and we evaluate that. So that will, let's have a go at that. So it'll be 3 times minus 1.7 squared plus 4 times minus 1.7. So let's work that out. So that is going to be 1.87. So that is the gradient of this line. And I mean, that makes sense because, you know, it looks like it's definitely a positive gradient. It looks approximately 1.87. That makes sense. So that would be the gradient. So let's use m as the gradient here, 1.87. But let's say we wanted to work out the gradient of this line. Well, we already know just by looking at it, the gradient's 0 because it's a perfectly horizontal line. But let's try and confirm that. Well, again, we're going to use dy dx is 3x squared plus 4x. But now the x coordinate is different. In fact, the x coordinate here is going to be x is equal to 0. So now let's sub x is equal to 0 into dy dx. So that will give us 3 times 0 squared plus 4 times 0, and that is 0, and that is confirmed according to our diagram. Okay, so let's look at a typical exam question. So we've got the curve C has equation y equals x cubed minus 2x squared minus x plus 9, and the point P has coordinates 2, 7. Show that P lies on C, or the curve. Okay, so the first bit should be straightforward. All you need to do is to sub in 2 as the x coordinate, because remember this is an x coordinate here, and sub in y is 7 into here, and just show that algebraically the whole thing makes sense. Okay, so show, for example, that 7 equals 7. If you get, say, 7 equals 8, obviously that doesn't make any sense, and that would be sufficient to show that P doesn't lie on the curve. So let's do that quickly. So that would be y is 7 on the left, and then on the right we've got 2 cubed minus 2 times 2 squared minus 2 plus 9. And if we work that out, then yeah, that is 7. So 7 equals 7, and therefore P lies on the curve. Okay, so let's look at B. So find the equation of the tangent to C at P, giving your answer in the form y equals mx plus c. So how can we understand this? Well, the equation of the tangent. So we've gone over in previous videos how to work out the equation of any straight line. And remember that a tangent is a straight line. And I mentioned in that video that whenever you see a question asking for the equation of a straight line, immediately you should be thinking of a few things. First thing is y minus y1 is equal to mx minus x1. So that is always, whenever you see a question asked for the equation of any straight line, including a tangent, you should be thinking of that. Now, what does that require? If we want to use that equation, we need x1 and we need y1. And remember, these are defined as a point that the line goes through. And 3, we need m, which is the gradient. Okay, so let's have a think about how we can do this. Well, we're told, if we were to just draw this just to get a feel for the question, it doesn't have to be perfectly accurate, but you know, if we drew something out very quickly, so that's some kind of curve here, and we said here's our tangent, let's just draw it in here, and it says the equation of the tangent to the curve at P. So this is P, and what are we told? Well, we're told that P is 2, 7. And so the 2, 7 are the x and the y coordinate of the point that the line goes through. So straight away we can say that x1 is 2 and y1 is 7. Okay, so we're almost finished here. The only bit that we're really after now is to work out the gradient. Okay, but we've just done a question on this where we want to work out the gradient of the tangent to a curve. How do we do that? Well, we do dy dx. So we need to work out dy dx for this question. Okay, however, what is the original function? The original function is this up here. So let's try and write dy dx down here actually. So dy dx is going to be 3x squared minus 4x minus 1. And then we need to sub in the relevant x-coordinate of this point of interest. Now, we know the x-coordinate is 2. So then when we sub x equals 2 into this, we will get 3 times 2 squared minus 4 times 2 minus 1. So that's going to equal 3. So our gradient now is 3. And so all we now need to do is to substitute all this information into the equation. So y minus 7 is equal to 3x minus 2. We could simplify that. So expanding that out, that's going to be 3x minus 6. And then if we add 7 to both sides, we're going to get y is equal to 3x plus 1. So that is our answer. That is in the general form y is equal to mx plus c. So that is the equation of the tangent to C at P. Let's look at another question. So here we have the curve C has equation y equals 9 minus 4x minus 8 over x. The point P on C has x coordinate equal to 2. The equation of the tangent to C at the point P is y equals 1 minus 2x. find an equation of the normal to C at point P. Okay, so let's have a look at this. So if we maybe do a quick sketch again just to get a feel for the question. Again, the actual accuracy of the curve doesn't matter too much, it's just really getting an understanding of it. So we know we have some kind of curve, maybe it looks like this again, doesn't really matter, and we know the equation of the tangent at P is 1 minus 2x. So let's actually draw that in. So maybe it looks something like that. Here's our tangent, and let's say P has coordinate x coordinate 2, so we can put 2 in here. Let's do that. So we can put 2 in for the x coordinate, and here's P. And we know that this equation is y is equal to 1 minus 2x. Okay, but now it's saying find an equation of the normal to C at P. Now what is a normal? Well, a normal is simply a straight line that's at right angles or perpendicular to the tangent. So here's our tangent. The normal would be drawn something like this. So we could make sure that we can draw in that 90-degree angle there. So this is the normal and this is the tangent. How can we work out the gradient of this normal? Well, again, an equation of a normal is an equation of a straight line. So it requires a point that the line goes through, and it requires the gradient. So we know that the x-coordinate of the point that the normal goes through is 2. So that's right, x1 is 2. Now we also need y1, and we need the gradient of the normal. Now the gradient of the normal is quite easy to work out because we know the gradient of the tangent. So the gradient of the tangent is actually going to be minus 2. So the gradient of the tangent, I'll just put m and then a little t to show the gradient of the tangent, that is going to be minus 2, because we know that the equation of the line is y equals 1 minus 2x, this being the gradient of the line. Now the gradient of the normal is actually going to be a half. Okay, how can we get that? Well, there's a property that says that if there are two lines that are perpendicular, and we know that the gradient of one of the lines is m, the other gradient of the line perpendicular to it will be minus 1 over m. Okay, or another way to look at it is you take one of the gradients, you turn it upside down, and then you put a minus sign. So we know the gradient of the tangent is minus 2, and we can actually write that as minus 2 over 1. It means the same thing. Then we want to turn it upside down, which becomes minus a half, and then times by a minus, which becomes positive a half. So that is the gradient of the normal. So let's write that in, a half. And then we just need to work out y1. That shouldn't be too hard, because we have actually two things we can do here. So we can, for example, sub in 2 into this equation, because we know that P lies on the curve. So that's one way to do it, but a much easier way to do it is actually to sub 2 into this equation, y equals 1 minus 2x, because P lies on both the straight line and the curve, and obviously subbing into this is much easier. So let's do that. So that will just become 1 minus 2 times 2, which is 1 minus 4, which is minus 3. And then it's just a question of subbing everything in to the y minus y1 formula. So y minus y1 is m x minus x1. So that will give us y minus minus 3, so that becomes plus 3, is equal to a half x minus 2. And then if we neaten that up a little bit, let's just write it down here, so that will become y is equal to a half x minus 1 minus 3, and then that will become y is equal to a half x minus 4. Let's look at the next part of this question. So the tangent at P meets the x-axis at A, and the normal at P meets the x-axis at B. Find the area of APB. So let's try and draw this out. So the tangent at P meets the x-axis at A. So here's the tangent. So maybe we could continue this along a little bit more to this point here. And then also the normal at P meets the x-axis at B. So again, we can continue this down like that. So let's write those in. So that would be B here, and then this would be A here. And we want to work out this area of the triangle APB. So basically this area here. Now we're not sure if this looks completely correct. It could equally be that this triangle is underneath the axis. So depending on how we've drawn this curve, it could be that the triangle's underneath, but actually it doesn't matter too much. You imagine, for example, the triangle was maybe looking like this. So here's our P down here, and this is the triangle. It doesn't matter too much. It actually probably is underneath, because if we look at the y coordinate of P, we found it was -3, so it should actually be underneath. But that's fine. A lot of the time with a sketch, unless they ask you for an accurate sketch and you get marks for it, it doesn't matter as long as it helps you to just get a feel for the question. So here, if we want to work out the area of APB, what we need here is essentially the base and the perpendicular height. So we know the perpendicular height is already going to be 3, because we know this y coordinate of P is -3, so this distance here is going to be 3, and then we just need to work out the x coordinate of B and the x coordinate of A, and then take away the difference to get the base. So how can we do that? Well, we know that this intersection point here is the intersection point of the line 1 minus 2x with the x-axis, and that is when y is 0. So we can solve to get A then. How do we do that? We can say 1 minus 2x is 0, and when we rearrange that, we will get 2x is equal to 1, x is equal to a half, and then if we do the same for B, well, we know this is the equation of the normal here. So for B, again, we're going to do half x minus 4 is equal to 0, and if we solve that, we get 4 is equal to a half x is equal to 8. So again, the diagram is kind of around the wrong way, but it doesn't really matter because it helps us to just get the answer anyway. So we know then it's the difference between B and A is going to be 8 minus a half. So the area of the triangle is going to be a half base being 8 minus a half, times the height, and that should be 11.25.